Welcome back to this video series of C++ programming. This is the lecture 10 of this video series, and today we'll talk one of the simplest topic of C++ programming, that is nested and local classes. Let's talk about nested classes. When one class is defined within another class, it becomes a nested class. Nested class is valid within the scope of enclosing class. So if you create a nested class within the enclosing class, the nested class cannot be accessed outside that enclosing class. So it has to be accessed through the enclosing class only. Because of a powerful inheritance mechanism, nested classes are seldom used in C++. Let's understand more about the nested classes through an example. First, I will create one enclosing class. I will call this as a class C1, and inside this, we'll create some members. So some private data members, say this data1 is a private member variable, and create some public members. So one member function that will display the content of this private data members on the console window. So here I will display the data1 content on the console window. I will specify some value to this data member variable here. Now inside this class C1, I will create another class, and I will call this as a class C2. Now this C2 is a nested class, and this C1 now becomes an enclosing class. Inside this class, I will create some private and public members. So I'll copy this code as it is and replace this data1 with the data2. Now inside the nested class, you can create the private members, public members, and protected members. So it is similar to a class, but only difference is this nested class C2 cannot be accessed outside this enclosing class C1. So let's understand why this is not possible. So if I try to create an object of this C2 class, compiler will throw an error. So it is saying identifier C2 is undefined. That means you cannot access this class outside the C1 class. This C2 class can be declared within the public or a private access specifier of the enclosing class C1. So you can specify it here or here. So at both the places it is possible. Even inside the protector access specifier, you can declare this C2 class. How to access this C2 class from the enclosing class C1? For that, you have to create an object of the nested class C2. So I'll create one object, say object 2, and through this object 2, now we can access the members of the C2 class. So this I'm calling this display data function, which is of object 2, and it is present in this C2 class. Now is here in the main function, I'll create an object of the C1 class, and we'll call this display data function. So now this display data function, it will get called and it will create the C2 object, and then it will call this display data function, which will display the content of a data2 followed with the content of data1. I will add one more statement here, infinite while loop, so that my program doesn't exit. So now let's compile a program and let's see what does it outputs. So it is outputting the value as a 50 and 40. This is how the nested classes can be accessed through the enclosing classes. Now in this nested class, you can access the members of the enclosing class. So how we can access? For that purpose, you have to create an object of the enclosing class. So I'll create another object of the enclosing class C1, and now with this object we can access both the private and uh, public members of the this enclosing class. So for example, now I will assign this data1 variable of the class C1 with value 60 and print this value onto the console window. So through with the help of an object. Now let's compile the program and let's see what does it outputs. Now it is outputting at the second place, it is outputting the value as a 60. So which is a value of this data1 variable, and this is the member variable of the class C1. So through the nested classes we saw how we can access the private members of the C1 class or the enclosing class. Similarly, we can access the members, the member functions of the enclosing class using the same object. But from the enclosing class, we can access just the public members. So if I try to access the private members, first of all, it is not possible to access the private members of the nested classes. So we can just access the public members. So that still holds the encapsulation properties of this nested class C2. Alright, so this is about the nested classes. Now let's talk about the local classes in C++. Local class is the class defined within a function body. The scope of the local class is within that function only, and all the members functions must be defined within that class. So let's understand these 3 points with an example. So here we'll create one function, and now I will call this function from this main function. Now as we saw, the local classes are created within the function. So inside this we create one local class. Say I'll call this as a my class, and now we can create the different data members, member variables and member functions, and we can use this access specifiers, private and public. So I create one private data member, and similarly I will create another public member, which so this is how we can create a class uh, inside this function one, and now this class is local to this function one. That means now this class cannot be accessed outside the function one. So if I try to access this class through this main function, then the compiler will throw an error. Or say, suppose if I try to create an object of this class, the compiler will throw an error. It is saying identifier my class is undefined. So these local classes are not accessible outside this function. So their scope is valid within that function only. So within this function, we can create an object of this class, and through that object, we can access the members of that the local class. So now with this object, now I can access this public member function display data, but I cannot access the private member functions. So this encapsulation property still holds for the local classes as well. So we can access only the public members with the help of an object. We cannot access the private members of that class. Now let's compile the program and let's see whether it is outputting this value 40 correctly or not. Yes, it is outputting the value 40 correctly. So this is how this local classes can be created and accessed within the function. The fourth point, the local class cannot use or access the local variables of the function in which it is declared. The local class has access to static local variables declared within that function or those declared as external. So let's understand about these 2 points. The first, local class cannot use or access the local variables So here if I create any local variable, say integer j, and if I try to access that variable here, so I assign some value, now the compiler will give an error. So reference to local variables of enclosing function is not allowed. So you cannot access the local variables within this member functions of the local class. And as we talked at this point, it has access to static local variables declared within that function. So if I change this variable to a static, then it is possible to access this variable. So now compiler is uh, not throwing any error for this variable j. So here I can print this value of j. Now since this is a static variable, as we saw, no matter how many objects of this class we create, only one copy of this j variable is created since this is a static. So let's see with this with an example. Here I will create one more function, member function, and I will call this as a set value, and I will pass the value to this integer value to this member function. And now inside this I will call this as v, and now I will initialize this data member variable value and this static member variable j with this uh, past variable v, and here with this object I will set the values for this two variables. So in this case, can you imagine what would be the values of this val and j variable? So let's see. So as you can see, it's outputting the value as first two values which are related to the object, first object, and it is printing the value as 38 and the j variable as 38. Similarly, in the second case, it is printing the value as 28 and the j variable output as a 38. So now the reason it is printing 38 for the j variable for both the object is because the j is static. So as we talked, since it is static, no matter how many objects we create, only a single copy of that j variable is created. That's the reason it is outputting the last value 38, which is assigned to a j variable. But the local classes can access the type names and enumerations defined by the enclosing class. So it can access the enum and the type names present within the enclosing function, the local function. And finally, no static variables may be declared inside a local class. So if I try to create any static member variable inside this class, the compiler will throw an error, which is saying static data members declaration is not allowed in this class. So this is all about the local classes in C++. I hope you have now understood the concepts of the local and nested classes in C++. So thanks for watching this video and stay tuned for the upcoming videos.